So we're going to start off with the first example. Finding x-intercepts. I've got y equals sine of x, so it's a sine of x graph. It's 0 to 2 pi. That's my domain. Okay, so I want you to find the x-intercepts. Now, how do you find the x-intercept? What do you have to do? Y is always equal to 0. So, first step, you're going to let y equal to 0. So I've now got sine of x equals to 0. If you want to find the x-intercept, your goal is to get x. You need to have x as the subject. Your problem right now is the sign. You don't want the sign. You don't want sine of x. You just want x. So how do you remove the sign? The sign's the issue. What do you do, Chi?
Sine inverse both sides.
Good. Sine inverse both sides. It's balancing the equation by sine inversing both sides. So I'm doing sine inverse of sine of x and sine inverse of 0. So I'm doing left and right hand side. It's kind of like your log and exponential. Exponential, which is the power of log, they cancel out. Same thing with sine inverse and sine. These two will cancel out. You can try it on your calculator if you want. You can do sine inverse of sine of 30 degrees and it will still come out as 30 because they're just undoing each other. It's like saying x times 2 and then divide 2. It ends up being x anyway. Okay? So here we have sine inverse of sine. We know that these are going to cancel out and you will get your x. Now this is where I want you to stop. Okay, once you get up to x equals to sine inverse of 0, this is where last year you were learning this and you found difficulty, it's here. Okay? The reason why it's hard is because you've been drilled in the pattern since year 7 to now is you always get an answer. You know, you do like, at this step here, you normally have, let's say, 3x equals 4, and you say, the inverse of times 3, you would say divide 3, and you do 4 and 3, and you get one answer. If you did quadratics, it's the same thing. If you got x squared equals 9 and you did x square root of 9, the only extra thing you learnt was it's plus minus. But then you still say plus minus 3. You only get one answer. In this case, it's 2. And linear equations, same thing. But when you got to circular functions in year 11, this could be infinite. So at this point, most students will then go to their exact values and go, oh, yep, the answer is 0. Because sine of what will give you 0, and the only 5 exact values that you learnt for sine, the sine of 0 gives you 0. So naturally you would say x equals 0, and you lose out on the solutions. Okay? This is where I want you to stop, and I want you to think about, well, to find out the number of solutions, this will be highly dependent on your domain. Because if your domain's infinite, then you technically have infinite answers. Okay? So it depends on the domain. So what I want you to do here at this step is to work with the unit circle, with the domain. That's the first step. You don't write the answer. At this point, you shouldn't be writing any answers at all. You should be formulating the possible answers. So here, I've got a domain of 0 to 2 pi. So I start off saying, okay, I got 0. I go around the unit circle, so it's all the way to pi. And then I go all the way around and I get to 2 pi, so I finish. Okay? Now, somewhere in between that, I'm meant to get my solutions. Now, the part that you need to understand is not here. Okay, that tells you the angle. What you need to understand is this. So what you're saying here is sine of some angle gives you 0, but it's not that. It's what does sine represent? See, sine represents the y values. What you're asking here is, in the unit circle, where around the circle will you have a y value of 0? That's what you should be asking. You should be asking yourself, where around the circle will I have y equals to 0? So you think about your y-axis, this is your y-axis. Where around the circle will you have a y-coordinate of 0? Where would it be? Logically on the circle.
Pi divided by 2 and 3 pi divided by 2?
No, at this point, this is where x equals 0, which is the cos function. Okay? At these points, your y value is the maximum. At that point there, that's when y is 1. And at this point here, that's when y is the maximum, negative 1. But I want y to be 0. So where would y be 0? At every pi or 0. Okay, at this point here, if I asked you the coordinates of this point here, so I'll color it in. This point here, the coordinates here would be 1, 0, because it's a unit length of 1. True? You would tell me that's 1, 0, and that's where y equals 0. So the only other point that you'd have when y equals 0 has to be over here too. That's when you have negative 1, 0. So logically, your answers would be at this point and this point, and that's when you have a y value of 0. See, if I changed the question and I said,
What about 3 pi here?
Yeah, I know. But I'm talking about the unit circle. Later on, you formulate. So you just need to know where do you get y equals 0. Then you formulate the answers. And you're right. It's 0, pi, and 2 pi. Right? But what I'm trying to get at is, if I change that question and I said sine of x equals half, what you need to understand is all the question's asking is, when are my y values equal to half? So logically, this is your y-axis. Half is right there. The only time you can get y values of half are those 2 points there. Yes, Leah?
What's the point of doing the inverse then?
The inverse is then to figure out how many answers you can get. So you just need to know where, and then as you move around the circle, it will tell you how many times you cross that point.
But what's the point of going x equals sine, like inverse of something, just use sine x 0 and like do what we just did?
Yeah, in this case, it was a sort of an easier example. That's why it works out to just be 0, like pi, 0, and 2 pi. I'll do an example where you don't have that. Okay? Guys, thank you. Let's do this example. Sine of x equals half. Let's go with that because the example we just did just now gave us 0, pi, and 2 pi. It was very obvious by looking at it, and you can tell it's 0, pi, and 2 pi, right? Let's do one where you don't get that. So let's do, same thing. I've still got 0, 0, pi, 2 pi, but the question now is asking you, when will the y values be half? Now you look on your y-axis, sine is your y-axis, you're saying when will it equal to half? Now around the circle, the only time you're going to have this y coordinate is at these 2 points. Those are the only 2 points. Right there. And right there. Those are the only 2 points that you're going to get a y value of half. So now you can say, all right, that means those are the 2 regions. The only problem right now that you don't know is what angle that's required, and that's what this step is for. So at this step here, you would say, all right, I don't know what the angle is because x is the angle. So to find out x, you would say sine inverse of both sides, you get sine inverse of half. The problem here is if you do sine inverse of half using your exact values with your hands, you only get one answer. And your answer is pi on 6. Okay, to get half, you need sine to have only one finger. So this has to be this one. Drop this one down. That means it's sine of pi on 6 will give you 1 over root 2. Okay, so here, this only tells you that this angle here is pi on 6. It also tells you here, this angle is pi on 6, and that's key. See, once you draw it out, it's obvious that, all right, you started at 0, you need an extra pi on 6. So starting from 0, you're moving up pi on 6. Okay, and that's what I mean by once you get the positioning, it's dependent on the domain how many times you're going to pass through there. Now I'm starting at 0, and I pass this point when I go 0 with an extra pi on 6. Whereas on this side, I'll be going all the way around and I cross that point, but I know here is pi and I'm missing pi and 6. So you would say pi, subtract pi and 6 to get that point. Does that make sense? Yes? No? So I'll write it again. So here we got pi, subtract pi and 6. So the reason why this is important is because if the domain was different, if I changed it to 3 pi to 4 pi, 3 pi to 5 pi, right? Then I'll be starting here and I'll be going around 3 pi, 4 pi, and then I'd hit my solution. So if I change the domain, it will change what you're solving here. But the positioning doesn't change. Positioning of these coordinates, it's still when is y value equal to half? It's those 2 points. What's the angle? It has to be pi and 6. But to solve it, that's what I'm doing. So instead of starting at 0, because that's what I'm saying, starting at 0, I move up by pi and 6. What if I change that to 3? Okay, then you'll be starting over here. You're moving around 4 pi plus pi and 6. That gives you the first solution. You go all the way around, that's now 5 pi. So 5 pi, subtract pi and 6, gives you the second solution. So it depends on what the domain is, will give you a different answer. Okay, that's why I mean, before you write your answer, don't go to exact values and go sine inverse of half, pi and 6, because we don't know if it's pi and 6. We don't know if it fits in that domain or not. Most of the time, your textbooks will work between 0 to 2 pi, but in your exams, it's not necessarily between 0 to 2 pi. It could be negative pi to pi. You get a different answer for that. Okay, so, in this question here, this specific point, it was pi and 6 to, what's that, 5 pi and 6. Okay, those are my two solutions there. But what I want to work with is changing that domain so that you're familiar with, the technique is still the same. It's still find x, sine inverse of half, but that's where you pause. Pause there, draw out which points you're working with, find out what the angles should be based on the exact values, and then work with the domain. Okay, so I'm going to do one different one. I'm just going to make it up right now. I'm just going to go to another one. I'm going to make it up. Let's try. I'm going to change the domain for this one too. Okay, let's make it a bit bizarre now. Let's do 5 pi to 9 pi. Okay, so I'm just going to work with a unit circle, and I'm just changing the question now too. I'm going to change the question to tan of something, tan of an angle to equal to, let's say, negative root 3. Okay? Now, in order to find x, you'll do the algebra. The algebra is pretty straightforward. Get rid of tan, you would? Tan inverse. So you'd say x is equal to tan inverse of negative root 3. Right? And then you try to write your answer. Now, at this point, I don't want you to write an answer, because it's not one answer. You have to formulate it. So pause there. Draw the unit circle. Here we go. Now we got to understand what the question's asking. And the question's asking tan of something is equal to negative root 3. What does tan represent again? It's not your x value, it's not your y values, it's your gradient. So where in this circle will my gradient be negative? Because I've got negative root 3. So I want the gradient to be negative. Now that's a positive gradient right there. I want a negative gradient. So which quadrants will it be in?
The top left and bottom right.
Good. Second quadrant and the fourth quadrant, we count backwards. Yeah, so 1, 2, 3, 4. Second quadrant, fourth quadrant. This is the only times you will have a negative gradient. So right now, all I know is, okay, at this point, I'll have a negative gradient. And somewhere over here, I'd have a negative gradient. What's my issue? I don't know what the angle is. I don't know what this angle and this angle is. But that's why you learnt your exact values. Now think about it. What angle would you have to have in order to get a gradient of root 3? We already got the negative gradient. We want a gradient of root 3. What angle should it be?
Pi on 3 or 60 degrees.
Good. Pi on 3, because if you dropped your fingers down to get 3 over 1, that's how you get 3. It has to be this ring finger. Dropping that down. That's pi on 3 or 60 degrees. 3 divided by 1 and square root it. Yeah, that was the formula I gave you. So I know this angle. Now I know the angle has to be pi on 3, pi on 3. And this is what I mean. You don't get an answer straight away. You formulate your answer. See, up to this step, you want to work with the domain. You're starting at 5 pi. You're going all the way to 9 pi. And anytime you cross these points, you write a solution down. That's why there are infinitely many. Now 5 pi is over here. All the odd pi's start here. True? So I'm going to start there. I'm going to move around the circle. So here we go. So starting from 5 pi, I'm moving around the circle. And I get over here and I cross the first solution. Now when I get over here, this is 6 pi now. My first solution should be, as I'm getting the 6 pi, I already crossed the solution. So it has to be 6 pi minus pi and 3, because that's less. Yeah, before I get 6 pi minus pi and 3. So that's my first solution. You'd write 6 pi minus pi and 3. And you go with the same thing, you continue the direction. You're like, all right, I've got my first solution, let's continue. 6 pi, I go all the way here, now that's 7 pi. But as I get to 7 pi, I cross another solution. But I'm less than 7 pi by pi and 3, because I already know what the angle is. So it'll be 7 pi, subtract pi and 3. That's my second solution. So I'd write it down. I was like, all right, well then it has to be 7 pi minus pi and 3. But I'm not done yet, because the domain said go from 5 pi all the way until you get to 9 pi. So I'm still at 7. Now I'll do another cycle. I've done one revolution, now I'll do another one. So I'm going to do another cycle, I'm going to continue. So from 7 pi, we go all the way here, that's now 8 pi. But as I get to 8 pi, as I'm going again, I cross the same point again. So that's another possible answer. It says 8 pi, but less. I've lost by pi and 3. That's how much I'm missing. 8 pi subtract pi and 3 will give me my other solution. So 8 pi minus pi and 3. And I'm still not done yet because the domain was 5 to 9 pi. So here we go. I'm at 8 pi. To get to 9 pi, I've got to do another half turn. I get here, which is 9 pi. And as you can see, I cross another solution. And it's 9 pi less. So that's why I would say the answer is 9 pi and subtract pi and 3. See what I'm doing there? I'm just going around the circle. So I go all the way here. That's 8 pi in total. That's an 8 pi in total, but I'm meant to stop here. And that's 8 pi minus pi and 3 to lose. Over here is 9 pi, but then I lose pi and 3. And that finishes the cycle. Me going from 5 all the way to 9, I've done 2 revolutions. From 5 to 9, I've done 2 revolutions, and I've crossed this 4 times. Which makes sense. Once, twice, 3, 4. So I have 4 solutions. So that's why I said that your number of solutions will be highly dependent on your domain. And why is that different to quadratics and why last year was difficult? Because you're not used to seeing it like this. 1, you're not used to the fractions. 2, you're not used to the radians. 3, it's weird that it goes around the circle and losing and adding. You know, we're going anti-clockwise as well, so it's a bit confusing every way. But the logic to it, you're just adding until you get those solutions. That's all you're doing. Yeah? So here, to finalize your answer, you simplify them. Now you say, 3 times 6 is 18 minus 1, so 17 pi on 3. 3 times 7 is 21 minus 1 is 20 pi on 3. 24 minus 1 is 23. Whoops, 23 on 3. And then finally, 26 pi on 3.
Let's just say that's plus 3.
Yeah, you could. Yeah, you could. I'm just showing you the sort of technique to it. That's all. How do we feel with that? Does that make a bit more sense on what you're doing? That's just recapping what you were meant to learn last year, and hopefully it makes more sense now on what you're actually doing. Okay, you're just working around the circle. Okay, let's do another example just to get your head around it. Okay, so because if you can't do this, then you can't do the example I want you to learn. The example that I want you to learn is not this one. It's your exam questions where we change the next value. Okay, and that's why today's double session will be good. I can train you to do the exam type questions. So exams won't be this question. The exam will always have a dilation from the y-axis because that changes the number of solutions you'll get, and most students will get it wrong. Most students will learn this skill. They'll pick it up because it's the first part of the exercise, yeah? It's always the later parts that most students don't do, yeah? And that's why they get it wrong. So the dilation is what I want to work on. That's your exam 1. It's likely to come up 2 marks. Okay, you'll get 4 to 6 solutions that you have to work with. If you don't do it right, you only get 2 solutions. So kids who get 2 are doing it this way. Kids who get 4 or 6 are doing it the right way. Okay, so let's work with this one. I want you to have a go. Same thing. Rearrange the equation. Our goal is to get x. I need to remove the 1. I need to remove the root 3. I need to remove the tan. As you're solving for x, remember, pause, draw the unit circle, work from 0 to 2 pi, and write down the solutions. Formulate them. Okay, don't just write an answer. It's not correct all the time. In our case here is 0 to 2 pi, so you're likely to get one of them right. Let's try this one.
Yeah, I took the domain.
It gets worse when you have lines and then they expand. We have double.
And then yeah, but it's like if I try and do a change, I'll forget that I want to. Yeah, I want to say and like the shortcut for sign and like
Solution for that, especially at all, because of the solution.
Which is like whenever you find the angle in radian applies to the denominators, the difference between the numerator and the numerical coefficient differs by that amount. So you have, as the last question, you had 17, 20, 23, 26%, but this one you have 5 pi and 11 pi. 6.
Yep, that's what I do too.
I have a question about one of the questions. I don't understand how I solve this question.
Alright, I'll finish off this one. Alright, here we go. Let's go through our solution. So hopefully you got up to this step. You move the 1 across and -1 on both sides. Divide both sides by √3. So you would have got up to this step here. To get x, you had to do tan inverse, and I told you to pause. That's where you pause. Your goal is to read what this means. And this means tan means the gradient, and in our case, we want the gradient to be negative. So again, it's the same, similar example as to what I did before. You can only have a negative gradient either in this region, or you can have a negative gradient in this region. Your problem is you don't know what the angle is. You don't know what angle it is. That's why you have to learn your exact values in 6b. So first question is, tan of what angle will give you give you 1 on √3? Because you already got the negative gradient. 1 on √3. Tan of what? It is pi and 6. It's your index finger. Drop it down. You got 1 divided by 3 and then square root it. So it has to be pi and 6. So I know the angle's pi and 6. This is pi and 6. It is not the answer as pi and 6. That's what a lot of students do first. They write pi and 6. That is not necessarily the answer unless it's between 0 to 2 pi. Yeah, and in our case it is between 0 to 2 pi. But I want you to change that habit. At this step, write out or formulate the possible solutions. So here we go. We're going to work with our domain. Starting at 0, and I start moving around the circle. So I'm starting at 0, I keep moving, and I hit my solution, but I land at pi. So that means I hit the solution before I even got to pi, so it's pi minus pi and 6. That's my first solution. Okay, so it's pi minus pi and 6. That's my first answer. My second answer, as I keep going, I need to get to 2 pi. That's my end point there. So I keep going in the domain, keep going, and I land at 2 pi. But before I land at 2 pi, I already hit another solution. And we can see I'm less of 2 pi by pi and 6. So your answer should be pi minus pi and 6 and 2 pi minus pi and 6. That's what I mean by formulating it. So depending on whatever the domain is, you're just going to work with the domain. It could be any domain. It could be pi and 3. It doesn't have to be 0, 2 pi, pi, 4 pi, negative pi. It doesn't have to be that. It could be negative pi and 4, and you're meant to be able to work with that. Okay, so here we go. Our final answer would be then, what, 6 minus, that's 5 pi and 6, and that would be 11 pi and 6. Hands up if you got those two answers. Good. Excellent. That's what I want you to just practice for this first half of this session. The second half, I will work with you to do, so this is the part of the question of 6E, but what I want to work on is that one. Okay, so we'll do, when you change the x to 2x, how do you work with that? And why do we do the technique I show you or we show you? And then I'll work with one where the domain is not 0 to 2 pi anymore, and you got 2x. Okay? And that should then allow you to do part of 6E, this question here. Okay, so that's where they change 3x, 3x, 2x. These are the kind of questions you can expect in the exam. So those are the questions that you would likely to get. Not the ones that you just saw before, these are the ones. Because you get 4 to 6 solutions, it's a 2-mark question. Okay? There we go, let's go back. And I just want you to practice that for now. And then we will go to do the second half of the lesson. Give you about 10 minutes. Shouldn't take too long. 0 to 4 pi. So work with the domain, 0 to 4 pi.
What if they're like application questions and the domain is pi?
Then that means the period.
Is there like a period money? Like yeah, no problem. Is that
Pi is this.
so then it'd be like 2 5 is like 5 6.
Oh, yes. It's moving.
The angle's also going to be the same.
2 just
Just happens that it's not a nice number.
It's 2 minus.
And then you got to do like times that 2 by again. And then minus it.
If you want to change it to radian one, you don't have to see it. That's fine. Like 2 is minus 6 is a number. Pi is like 3.152. Like it's whatever that decimal number is.
It's like, you don't know what that number.
So it's these questions. With 6 zeros, what was the answer?
Actually, it's part of it.
That's why you want to convert the angle and then do sine convert.
Yeah, like or you got
They're scientists. They're big scientists. And then sine of negative 7.4 should still be
It's like, you guys
Matt. Two hour example.
Yes, there are multiple answers.
Sure.
No.
What happens if like you do all the technique right, but you fail to simplify?
Not good enough.
Did you get it wrong yet?
Yep.
Watch myself. Yeah. It's gonna happen.
Yeah?
I know it's gonna happen.
That's my goal, huh? Just look at your sack.
Just look at my sack and you go, what the sack? It's like, you did all the working right, you even got the answer right, and then you just see me like, what's 2 pi minus pi over 6? And then it's like, 4 pi over 6.
That's not what I want to hear, Jack. It's like you want it to happen. It's gonna happen.
Afterwards, you're like, oh.
No, it's not. Fucking good. That's fire, boy.
Look at it. It's 2 centimeters. That even looks like 2 centimeters.
Alright, what's this one? Wait, I think both. Why did it say that?
Why don't you not that? Two minus two.
No, just reading that.
Absolutely. All right, Jack. Got to get to my speed.
Because like he's the main one, yeah, it takes equal to 5. Kind of speed. The speed you need.
Yeah.
Bitch.
Get him back. Did we cover
Find it to answer
like stationary and identity?
Yep, cos squared theta plus sine squared theta. And we also did vertical axes last week. When I taught C, I taught C twice.
All the stuff was on that Thursday apparently. All the stuff that complicated Friday. So I had to use textbook.
Yeah, it's just
How
yeah.
does it actually work? I drew a diagram, but I don't get it.
Give me an example.
No, I mean like the sine bracket 2 pi divided by 2 plus theta bracket is equal to a is equal to cos beta.
Yep. Think of it this way. You just said sine of tan 2 plus theta, right? Okay, that's a key thing. So when we draw it, literally draw what you just said. So we just said pi on 2 is the angle. Pi on 2 is here. Sure. Adding theta means that you are now moving on the unit circle. You've moved forward by that amount. Sure. So this is theta. Now that gives you a right angle triangle different to what you're used to. You've always been starting on the x-axis. You're now starting on the vertical axis. But the triangle that you've drawn is nothing unfamiliar. It's just true. Now, if I told you to label the sides in a triangle, this side will be called the
The
opposite. So I'm going to call it O. What's this called? Adjacent hypotenuse. True. So that's my triangle there. That's my O. That's my A. That's my hypotenuse. Now, when you say sine, what are you finding again?
it's equal to the opposite divided by the hypotenuse.
But remember, sine represents what values again?
Remember if I replacing the I with the Y because you still get sine.
Isn't it like the y value?
Y values. Now you see when we drew this point here, that's a coordinate. That coordinate has an x coordinate and a y coordinate. It means it goes across by a certain x length and it goes up by a certain y height. Sure? So when you ask for the y values at this point, you're really just asking this length.
Which is negative the other side.
Not negative the other side. Right now I'm just asking what is that height there, which represents in this triangle A.
Yeah, and that would be adjacent to the dotted line. Dotted line is adjacent.
Yeah. So the length here is equivalent to the adjacent.
Yeah.
True? So when you're saying here, sine of this, you're actually looking for the adjacent side. True?
Yeah.
Now, if I drew this triangle according to what we're familiar with, if I drew it like this now, okay? So this is the angle that we're used to. So that angle theta, whatever it is, let's say 30 degrees here, then 30 degrees by comparison can be here too. So if that was 30, this is 30. True? Now if I drew this triangle at 30 degrees, then this length here is your adjacent. This is your opposite, true? Now, that there, how do you find this length?
Sine. Oh, no,
Cos of?
adjacent. Cos of theta is 30.
Good. Cos of theta will tell you A, true? So this would be cos of theta. That will tell you this length. But this length here is also A.
Cos of theta times hypotenuse.
Yes, but remember unit circle hypotenuse is 1. So it just becomes cos of theta. But you just told me A equals the cos of theta. This is also A, and your job the whole time was to find A. So another way of writing this is, and that's the first property. And that's why I'm saying you don't need to memorize these properties because there's 4 of them, but it doesn't have to be pi and 2. It could be 3 pi and 2. It could be negative 5 pi and 2. It doesn't matter where it is. The point is to figure out this triangle relevant to the x-axis triangle. So you could have a triangle down here starting at 3 pi and 2, and you could say minus. So you could have this triangle. So that triangle there will have theta. And that triangle there would represent 3 pi on 2 minus theta. But then it depends on what I'm looking for. If I'm looking for this length, then you'll be calling that cos. Okay, so this cos here, that is equivalent to the sine. See, this is your opposite side. This is your opposite side. See, so I'm relating this length to this length. And I would say, oh, well, technically, this length is in the negative x region. That's a negative x length. So this should be equal to negative of whatever that value is. To find that value, it was sine theta. Because sine of this angle will give you O. And that will give you O, but I know that O has to be a negative.
Why are you looking for adjacent?
Because we said sine, which is the adjacent, the height. So at this value, you got an x coordinate and a y coordinate.
Yeah.
So this would be to find out y value, you would say sine of pi on 2 plus theta. Tells you the height. This would be cos of pi on 2 plus theta. That will tell you the length. But what you realize is this height is the adjacent of that triangle. The adjacent of that triangle is also the same adjacent as this triangle. Yeah? That's where it's coming from. Alright, let's do dilations from the y-axis. This is what you must learn. So, let's try this example here. Same drill, everything is the same, except for one small thing. Here we go. So if I were to do this problem, I would do the same thing, move everything across, add the 1 on both sides. I get 1 equals to 2 sine 2x. Then I would divide both sides by 2. You get half equals sine of 2x. Now here, if you would have solved for 2x, what you would have said is 2 times the x equals to sine inverse of half. Okay? Reason why most students get sort of confused here is that they divide both sides by 2. So you're not meant to. So you don't divide by 2 now because you don't know what sine inverse of half is. There are multiple answers to that. You need to formulate this before you divide by 2. Okay? And why do most students get this wrong? Is because when they do this, they treat as if the 2x is no different from x. It does change something. When you put a 2 in front of the x, what does it do again? What does that 2 do? It changes the period. It's a dilation of factor half from the y-axis. It compresses it. So if you think about it, if I normally have a graph that was a sine graph, this will be 0 to 2 pi. Oh, sorry. There'll be 2 pi there. If you compress it what you actually now get, which I'll do in blue, you will now get, that's one cycle, that's 1 pi. But in between 0 to 2 pi, you will now have 2 solutions. You see, you got 2 cycles there. There are 2 cycles. So technically, the number of solutions you would have had has doubled. That's why it matters whether you have 2. And if you don't change the domain, okay, if you don't change what you actually have, this whole thing is going to get really, like, you only get 2 solutions when there's meant to be 4 or 6. That's why the examiners do this. Okay, so you might get the first part of it, but you lose on the second half. So how do you do this question? This is what we do. Since x was an element between 0 to 2 pi, okay, and we know that there had to be 2 cycles. True? So the graph that I just drew before, we knew that it had to be 0 to pi, and you draw another one, and that's now 0 to 2 pi, pi to 2 pi. True? The problem with that is your unit circle changes. So your unit circle now, to do 1 revolution, 1 cycle, it's no longer 0 to 2 pi. 1 revolution is now 0 to pi. So if you were to work with this, this is what you would have had to do. You would have had to go, all right, pause, draw the unit circle, but instead of saying 0 to pi, it is now pi on 2. Because a full circle is pi. Now that's tricky, because every time I change the numbers, if I change that to 3, that will change this. And you get ugly numbers, and we don't like a unit circle with different endpoints. So how do we combat that? How do we change it so that it's something that we know? We know it's 0, pi, 2 pi. We like that. That works nicely, right? So what we said to ourselves, we're like, okay, well, I don't like the pi and the pi and 2. That just makes it really difficult. So what I want to do is, I know there's 2 cycles. So why don't I just do 2 cycles of that normal graph? See, instead of doing like this, instead of compressing it to pi, why don't I do it like this? Why don't I say, all right, I'll have 2 cycles as well. That's 1. That's 2. That's fine. You can make it longer, you get the 2 cycles, and then you halve it later. Because whatever the answers are here, everything here, whatever the answers are, halve it later. By compressing it later, you'll still get the 4 solutions you need, but it's easier to work with because in this particular example, it's still 0, pi, 2 pi. And we like that. That's better than trying to work with this circle where it's 0 to pi. And you try to double that. That takes longer. Because it might not be pi, it could have been pi and 3. It could have been pi and 3, and then now it's tricky. See, if it's pi and 3 to make 1 cycle, you'd write, all right, that's pi and 3 here. Then what's half of pi and 3? Then you say, well, that's pi and 6. And then what's half of pi and 6? You know, that's pi and 12. That's not an angle you want to work with every time. So what we do instead, since we know that having 2 will make it 2 cycles, we change the domain by 2 cycles as well. So how do you do that? This is what we do. This is the technique that a lot of students forget, and that's why it's in the exams. So here we go. We got 0, x to 2 pi. We want to keep it as a length period, still 2 pi. So we're going to say now, if I had 2x, that means I double everything. So 2 times the x. So that means it's 2 times the 0 and 2 times the 2 pi. So this now becomes 2x is equivalent to 0 to 4 pi. Does that make sense what I'm doing there? So it doesn't matter what these endpoints are. If this is a 2x, that means twice whatever x is. So I'm twicing the intervals. Okay? And so my intervals now are from 0 to 4 pi, and I do everything exactly the same as before. I still have my unit circle. I still ask myself, what is the question asking? The question's asking sine, when are my y values equal to half? That's what it's asking. So I look at my unit circle and say, all right, well, when will I get y values of half? Whoops. Let's go. Oh my God. Oh, here we go. Sorry. Red. Here we go. Is that red? Yes. Half is right here. That's where my y values is half. And so I'm going to say, since this is where half is, how do I get those 2 points? It has to be here and here. That's the only times you're going to get a y value of half. Those 2 points. So that means I have that and that. What's the problem? I don't know the angle. I don't know what the angle is from here to here, and I don't know what the angle it is from here to here. But that's why you learn your exact values. Sine of what gives you that half. So I want to know what angle I need to have so that sine becomes half. What is it? Pi and 6. So using your fingers again, you want sine to have only 1 finger, so drop down the index. That gives you sine as 1 finger, so it has to be pi on 6 as the angle. Okay? Now that you got the positioning, you got your unit circle, and you got your new domain. New domain is from 0, starting from 0, and you're going to work around the circle until you get to 4 pi. What you should expect is 4 solutions. You shouldn't have 2. Okay, so let's try that. Starting from 0, I'm going to start from 0 here. I'm going to move around the circle. And what you can see as I move around the circle, I hit 2 solutions. My first one, starting at 0, I hit the first one. At 0 plus 0.6. Then I move all the way here, I cross another solution. But that's at pi, subtract 0.6, because I'm losing by 0.6. Okay, so I'll write my solutions out. I say, all right, at this point here, I should have 0 plus 0.6. I should have pi minus 0.6. That gives me the first 2 solutions. But I'm not done yet, because I said the domain has to go from 0 to 4 pi. I've only just made it to pi, so I gotta go. I go all the way around, so from pi, I continue, 2 pi, I haven't hit anything. So now I'm back at 2 pi, and I continue again until I get a 4 pi. So I go again, second cycle, I hit a solution, and I hit a second solution. So that's now at 2 pi, going my second time I hit my solution once more, so 2 pi plus 0.6. Go all the way here, that's now 3 pi, but I'm less of 3 pi by 0.6, so I'll write it down. Right, okay, these are my solutions. I have now 2 pi with an extra 0.6, and I have 3 pi but less of 0.6. That's at 3 pi. Finally, I finished the cycle by ending at 4 pi, and that's done. I went from 0 to 4 pi, and every time I crossed those points, I wrote it down. So now I have all 4 solutions, and that's meant to equal to 2x. That's pi and 6. This is 5 pi and 6. This is 13 pi and 6. This is 17 pi and 6. Equals 2x. But remember, these solutions were stretched. We did 2 cycles of 0 to 2 pi. That wasn't correct. The domain was initially 0 to 2 pi. It doesn't make sense to have 17 pi and 6. That's way out of my domain. But the reason why it was way out of my domain is because I said, let's keep the same circle, but double it. But because I doubled it, now my final answer, I should halve it. Because that's what 2x was. 2x, I made it hypothetical. I said, let's work with 2 cycles instead of just halving it. Let's work with 2. Makes it easier. So I've got 2 of them. Now to get x, which is this domain here, I have to remove the 2. That's why you don't remove the 2 at the start. You need to get all the solutions first. Now you halve. Then you say, all right, let's get rid of the 2 now. I'm going to divide everything by 2. Divided by 2, divided by 2, divided by 2, divided by 2. Therefore, x has to equal to half of pi and 6, pi and 12. Half of 5 pi and 6, 5 pi and 12. Half of 13 pi and 6, 13 pi on 12. And then finally 17 pi on 12. And that makes sense now. 17 pi on 12 does not get past 2 pi. Because 2 pi would be 24 on 12. Okay, and I've only got to 17. But that gives you 4 solutions. Most students, when they're doing this in the exam, get that. Okay, without these extra 2. And that's what I'm saying. So the examiners will try either with the 2 or the 3, or they change this domain. Might not be 0 to 2 pi. It could be pi to pi and 3. It could be negative pi to pi. It could be negative pi to 0. And your goal is to be able to work wherever the domain is, but the technique's the same. I haven't done anything different. 6E there. Same style. How do we feel with that? Okay? I want you to try the next one. Here we go, you do that one. Same drill.
I don't remember. This is the correct answer to 1K.
Hey, is that the one with 10?
That's the one with 10. So they use the thing with I made those here.
I try and explain it. So since the two negatives, the negatives cancel out, and then your tan is that. Then I try to solve sine cos tan. So sine theta is equal to cos theta times tan theta, and cos theta is equal to sine theta divided by tan. And I sub those in. So I got sine theta. This is actually 1 because this is myself. So sine divided by cos is tan. So I got tan theta divided by tan 1 over tan beta squared, which then comes out to be 1 over tan theta. And then I sub 0.7 into tan theta, and I got that. Why is that so complicated?
Yes, because you made it
more complicated. But we don't have data for any of the variables besides that.
No, exactly.
When you say we can say that's equals 0, what is that? Yeah. 0.7 is the same thing. Oh, I think so. But I still did correctly. No, you did. Yeah. I'm proud of my averages.
Yeah, I'm pretty proud of it that you made a mistake, but that's all correct.
It does look terrifying, bro.
Yes, it does.
Why is this a question?
All the tans are tricky. All the
It's
tans.
like you have to find the inverse graph. I
Oh,
mean, the intercepts.
Yeah.
Two graphs.
Yeah.
The easy way is to say is equal to x.
yeah.
Because we sub for two y's is because it's reflection in the y is x.
Yep.
Y. That's the short way. I didn't know about. So I tried that one way.
Yeah.
And that's why I wasn't able to do that numerical question at the end of one of the things, which had no numbers, only letters.
Oh,
To
yeah.
find the answer.
Yeah.
And I got this way too complicated block of text. That was the answer.
You want to sign me this?
You are a funny one. Alright, let's write out the answers here. We got tan to be negative, so it has to be over here. Tan's negative. Angle has to be pi on 3.
You really don't have to do like your
How's that view? Pi on 3, good. Okay. And 3x change to 0 to 6 pi. Therefore, saying at 0, pi. Whoops.
It's really hard.
Oh, so you guys started?
Yeah. For some reason, well, I had about that at the same time. Then it goes to here, and then shit happens when it starts working.
Check your answers. Hands up if you got them correct. Good. Excellent. Teaching well. Just keep going around the circle. Get the circle right and just work with the domain. So I can see it's every pi losing a bit. 2 pi lose a bit. 3 pi lose a bit. 4 pi lose a bit. Keep going. Key thing is to change the domain.
Yeah.
Make sure to change that domain.
Like where was
I went to grade 8. And I was like,
Alright, once you got that, last example, and that's it for today. I've changed the domain this time, so it's not 0 to 2 pi. I still kept it easy. It's still a cycle, negative pi to pi. I don't think the exams normally go with pi and 3 to pi and 6 or anything like that, but I just... No, because there's just too many fractions, that's why. But they will change it. They will change it.
You know what? I would want to make it harder for you, but then it has to be hard for me to mark soon. I'm not doing that.
Exactly, because it's only 2 marks. It's only 2 marks.
It's like, you know what? I can't mark this in like 5 seconds. I'm not doing it. That's exactly what I'm doing.
Has there been any markers who've protested some of the questions that you
Especially like,
Yeah.
with me.
It goes through a voting. Yeah. They'll go through it and they'll vote for it.
So I know that with some of the science facts, they've said almost answers if there isn't maybe we got the exact answer. So if the exact answer was like 0.1% of people got, they might let people who got a very close answer like made a mistake. If not like wrong significant figures or something like that. Is it like that?
It would be, but it's again, all of those cases are very rare. They try to minimize that problem, so they don't have to change things. But yes, they would have to.
Except for one question. One question has 1 mark indicated. Every other question does not require. So even if you put the wrong unless you happen to have the question that had the significant figures. The only way to do that is either to go through that paper or basically find some one that says that basically.
Oh no, if you get a time data and you want to get a substitute
It should be more than
well, the answer is 10 divided by 7.
well, that beta is 0.7. Each one
Yeah,
over 10
I
beta.
got to it.
So 1 over 2.7 should be for that. All I do is like 10 beta, whatever this is, I just make it. If this quadrant is positive for 10, you just think positive, and just put 1 over 10.
I just because these were like this and they make them cancel out, you sub in the inverse from the tan equation.
It's like sine. It's like
No, right? So better right there than up there.
It's like sine pi on 2 plus whatever. And you know how that equals cos beta, right?
Yeah.
Because the side in the second quadrant is positive. So you just keep it as positive and you convert it to cos beta. It doesn't really matter whatever it is. It's like sine pi on 2 plus beta. You take cos beta. Because 3 pi on 2
minus that.
yeah, sine here is negative, so therefore you take cos beta. You just keep working around that.
So what is this?
Tan is just 1 over tan, but because this quadrant is positive for tan, because this 3 pi also minus, because this one is positive, just make it positive.
So I did just rearrange the tan equation and stuff today. I did just cancel it out because these two is tan, and then so this tan times 1 over tan squared.
This one, just be careful with the negatives. That's the only time I can imagine you making a mistake. Otherwise, check your answers. Get your domain correct. Work around the unit circle. Remember, minus goes clockwise. Adding goes anti-clockwise. And if you forgot what clockwise and anti-clockwise is, look at a clock.
My cheats.
Oh my god, imagine. I'm like, hey, can I buy the You join a circular function on it, you intercept it, and you're like, oh yeah.
That's right. Anti-clockwise, clockwise.
Which way's clockwise again?
Oh yeah.
Oh.
Yeah, just watch the hand move. You're like, that's clockwise. Moving on. Alright, that's it for today's lesson. That's just solving 6E. Make sure to practice that. That's your bread and butter. Without that, you can't sketch properly.